So in today's class, we are going to discuss two-phase method. Earlier, we have discussed graphical method, simplex method, Degen where we need to add artificial variable. So the same method which we are doing, that if there is need to add artificial variable, then we can also proceed to two-phase method. But is the advantage of, as it's So as its name indicates, there we will discuss two phases, right? In phase one, I have already told you that the first phase is that we consider the auxiliary objective function, right? What was the auxiliary objective function? I have told you that when we do begin method, if I have maximization case, I do minus m into my artificial variables. And if it is my minimization case, I do plus m into artificial variable. The same if I give m value as my m is equal to 1 and I consider only the artificial variable, that will be my objective function, auxiliary, that will be a maximize minus 1 into your artificial variable, and some of the books just write minimize 1 into artificial variable, because if you take the negative common, it will be minus 1 and it will have only artificial variable. Finding the maximum of negative things is this the same as you find the minimum of the positive. So you can also go in that way, and we will proceed to the second phase only when artificial variable will not present in the table, and if it is present, then artificial variable should be 0. By we can delete that variable, that will be the leaving, and we can decide one more basic variable. Only in that phase we can proceed to only second phase, right? So we will start with an example. So if your example is maximize z, which you have to use, solve with two phase 5x1 minus 4x2 plus 3x3, subject to I have constraint, that is 2x1 plus x2 minus 6x3 equal to 20, and this is 6x1 plus 5x2 plus 10x3 and less than equal to 76, and my third constraint is 8x1 minus 3x2 plus 6x3, that I am saying less than equal to 50, and I am taking all my x1, x2, x3 equal to greater than equal to 0. Since we have to solve it by two-phase method, right? So the basic thing is whenever we have to go for your simplex iteration, we have to convert it into the standard form. So if we are converting into the standard form, the first thing, I do not require any slack or surplus variable. So it will be plus 20. It is 6x1 plus 5x2 plus 10x3. Here I need to add one slack variable. I am giving name S2 as 76. Why I am giving name S2? Because so that I can remember that I have added my slack or surplus variable only in the second constraint. So this is just a notation. So it is your wish. You can give any name, S1, S2, S3. So since I am adding in second constraint, so I am giving name as S2. 8x1 minus 3x2. The benefit is that when you will do dual theory, you will have benefit of this by giving this name, right? Because I am adding slack variable in the third constraint, so I am giving name as S3. This is my 50, and all my xi and all S2 and S3 all are greater than equal to 0. And more thing, whenever we have to write now objective function, we cannot write the same. Now, since we have to solve it by two-phase method, so if we are considering the phase 1 of my two-phase method, so to solve this, we have to add one artificial variable over here so that I can have identity matrix as my basic feasible solution for starting the iteration. So now, because this is my maximization case, so my objective function can be minus 1 into my artificial variable A1. Suppose this inequality was your greater than instead of less than. So what you have to do? You have to do minus S2 over here. So then you have to add one more artificial variable, in that case plus A2. So in that case, your objective function becomes minus A1 and minus A2 and so on. The similar way, you can proceed. So however many you have artificial variables that you are adding in greater than inequality, or you are adding it in your equal to constraint, so you have to add your artificial variable corresponding to that. But in this problem we have only one artificial variable, so we can start with this, right? So because since we have taken this, now we have to start the phase one. That means we have to start my simplex iteration. I have to start my simplex iteration. What was that? I have to construct the table. So if I have to construct the table, I have to write my basic variable zj minus cj and my solution, everything, right? So we will start. So here I can write the columns. That will be my x1, x2, and I have variables name. That is my x1. I have variable x2, x3. I have added one artificial variable in the first constraint, s2 and s3. And this is my xb. Some of the books writes it is solution. This is zj minus cj. And the first entry is only the columns of my a. That is 2, 6, 8, 1, 5, minus 3, minus 6, 10, 6, and A10000100001, and this is making identity matrix, so that we can take my basic variables will be my A1, S2, S3, the cost coefficient corresponding. Now we are in phase one. So in the phase one, the cost coefficient of only A1 is present, that is -1. You can see S2 is not present, so it is 0. And all whatever you will have, this is your 0, right? So now that I have already explained you, whenever we have to write zj minus cj, I can write like this 0, 0, 0, 1, negate the sign of this. This is 0, 0. But zj minus cj corresponding to your basic variable, it should be 0. That means for A1, it should be 0. S2 should be 0. S3 should be 0. So there is no problem in S2 and S3, but for correspondingly A1 should be 0. So I have already explained you, either you can use your row operation or you can use the formula Zj minus Cj. How I can calculate that is Cb alpha j minus Cj. So if I want to calculate Z1 minus C1, I'll calculate it for 1 and I'll also show you the row operation, right? Now my my variables cost coefficient are A1 is my -1. This is 0, 0. Alpha j is my first entry, that this is my 2, 6, 8. And the cost coefficient for phase 1 we are discussing. For the phase 1, x1 is not present, so it is my 0. So if I'll multiply, you can notice you will get -2 over here. So this is -2 entry over here. Either you can, I have told you, you can use your row operation. What row operation you will apply? That your R naught. Row operation you can only apply when you negate the sign over here and you will write here. So you make 0 this thing with the help of this one. So you can apply your row transformation. That is your R naught will be R naught minus 1 times your R1. So it will become 0 minus 2, 0 minus 1, that will be -1, 0 minus this of -6, that will be 6, 1 minus 1, 0, 0, 0. And earlier also you write solution here as your 0 and 0 minus 20, you will get here as your -20. So you can notice over here this thing that you have used row operation or you can use your column operation formula, right? So now we have to start the simplex iteration, that is the basic step. So since we have taken the objective function to be maximum and -m, so the most negative to be entered, that means my entering variable here is my x1. So if x1 is my entering variable, I have to decide my minimum ratio. Minimum ratio is xb divided by my entering column, and entering column should be greater than 0. So I'll divide, but I'll divide 20 by 2, right? That is my 10. 76 by 6, that is my 50 by 8. And whatever is minimum, this is your minimum, you can check. So what is my pivot element? I got this 8 as my pivot element. So what you have to do with pivot element? Make pivot element 1, all other element as 0. So next operation you will apply. So it will be your Zj minus Cj. A1 will be on its place, S2 will be on its place, and on place of S3, what will come? X1 will come. This is minus 1, 0. Again, we are in phase 1 and we are dealing with auxiliary objective function. There I have only variables that. So what row operation I can apply? That I will divide R3 by 8 to make it 1. So it will be my 1 minus 3 by 8. 6 by 8, 0, 0, 1 by 8, and this is my 25 by 4. And the same operation I will apply at 0, so I can apply the row operation on R2. R2 will be R2 minus 6 times your new R3. So when you will apply your operation, this will become 0, this will become 29 by 4, and this will become 11 by 2, this is 0, 1, and this is your minus 3 by 4, this is your 77 by 2, and this you have to also make 0, so you can apply your row operation. R1 will be R1 minus 2 times your new R3. So when you will apply this operation, this will become 0, 7 by 4 minus 15 by 2. This is 1, 0 minus 1 by 4. And this is my 15 by 2. And this entry you also have to make 0. So what operation you will apply on R0? R0 will be your R0 plus 2 times your new R3. So that entry will become 0 minus 7 by 4 minus 15 by 2. This is your 0, this is 0, and this is 1 by 4, and this entry will become my minus 15 by 2. Now again, we cannot stop the iteration. Why? Because my objective function is maximization. My Zj minus Cj should be positive. That means this is my entering variable. If this is entering, we have to decide the leaving. The leaving will be the same. We will find the minimum ratio 15 by 2 divided by 7 by 4 because this is positive. And this is, I'll calculate, this is 77 by 2 divided by 29 by 4. So you can check, this will give you minimum ratio, and my pivot element in this case is my pivot element. So I have to make this pivot element as 1, this element 0, 0, and this again 0. You have to apply your row transformation. You have to apply your simplex iteration until you achieve your optimality, that your Zj minus Cj should be greater than equal to 0. Once you got Zj minus Cj equal to greater than equal to 0, then you can stop there. And if artificial variable is not present, then we can go to phase 2. If artificial variable will be present and it is non-zero, we will not proceed to phase 2 and we will just say that it is my infeasible solution. But now, since in the next iteration, now my this variable x2 will come, as here it will be s2 and here it will be x1. So the very cost coefficient is 0, 0, 0, and you apply your row transformation, that you make this element as 1, you can make row transformation that you just apply, that you will multiply it r1 by 4 by 7, it will become 1. So this entry will become your 0, 1. This will become minus 30 by 7. This will be 0. Once your artificial variable leave the basis, you can leave that. Constructing its column 0 minus 1 by 7, and this is your 30 by 7. And this entry, when you apply your row transformation, that is your R2 will be R2 minus 29 by 4 times your new R1. So this entry will become 0. This entry will become 0. This will become minus 256 by 7. And this entry will become 1, 2 by 7. This is 52 by 7. And this entry will become R3 will be R3 plus 3 by 8 times your new R1. So this you can make entries. This will be your 0. This will be, this will be 1, 0, and this will become minus 6 by 7, this is 0, this is 1 by 4, and this will become 55 by 7, and this entry you also have to make 0, so you can apply your row operation, that is R naught will be R naught plus 7 by time 4 times your new R1. So this entry will become 0, 0, and this is your 69 by 7, this is also 0, this is, we need not to calculate, this is 0, 0 and 0. So you can check even. Now your objective function has only artificial variable, and artificial variable is not present to this. So that's why this value is your 0. And now since your artificial variable is not present in the last iteration, so that means now we can proceed to phase 2, right? Now when we have to proceed phase 2, you can consider the last table as it is, which you have obtained like this. This is your last table which you got. Now this was your last table that we got, right? And now when we got this table, when you obtain this table, obviously when your artificial variable is not present, so you can, even when you have to construct yourself, you can remove this column. So this is the column of x1, this is the column of x2, this is the column of x3, and this is the column of s2, and this is the column of s3. And only what will be the change in this, when you are having that variable, don't write its zj minus cj value. Why? Because now we are proceeding to phase 2. So we will consider the actual objective function which was given to me, 5x1 minus 4x2 plus 3x3, and corresponding to your slack variables, it should be 0 into 0, s2 and s3. So what is the thing? Only we have to calculate my zj minus cj. My zj minus cj, you can do it in two ways. Either you can use the formula, that is zj minus cj is nothing but cb into alpha j minus cj. So you can calculate, because if you are calculating z1 minus c1, that will be cb. Now cost coefficient corresponding to x2, this is my minus 4, corresponding to s2, this is my 0, and corresponding to my x1, this is my 5, and my alpha j is my 001, and my cj is the cost coefficient, and you will get 0 over here. Or the other ways, I have already told you that you just negate the sign, that this is minus 5, 4, minus 3, 0, 0. Now you want that corresponding to your basic variables, zj minus cj should be 0. So you can apply your row transformation. How you will apply your row transformation? That you have to make this element corresponding to x2, this should be 0, and corresponding to x1, this should be 0. So with the help of the 1 which are in their corresponding row, so you can apply your operation. If you negate the sign, only then you can apply your operation, right? So my operation here, that will be my, I will operate on my R naught, right? So I will operate on my R naught. R naught will be my R naught. If you notice, you have to make this as 0 with the help of this one. So that means you can have to minus 4 into R1, and this you have to make, this is plus 5 into your R3. So when you will apply even this operation, you will get Zj minus Cj correspondingly to that 0. And here you will get also as 0, you can calculate. So this is coming out to be your 69 by 7 and 0, and this is coming out to be your 13 by 14, 155. And you have to calculate obviously your solution here. You write here 0, and this you will apply your operation. 155 by 7, or this way you calculate what is your Z, you know that is your CB into XB. CB is that minus 405, XB is this. When you will multiply, you will also get 155 by 7, or when you will have apply row operation, you will also get the same answer. Now, my objective was maximization. I can stop only when my Zj minus Cj all are greater than equal to 0. So now you can see in this table, when you have proceeded to phase 2, when you have done the calculation, your Zj minus Cj all are greater than equal to 0. That means I can stop over here. So that means what is my optimal solution? So my optimal solution is that my x1 is 55 by 7. X2 is my 30 by 7. X3 is not present, that it means it is 0. And my optimal value is 155 by 7. And this is my answer. Suppose in this case, this becomes your negative when you do the calculation. It can become negative. That means you cannot stop the iteration because it is of maximization. So this will be the entering, and then you will decide the leaving variable and so on. That is the same as you have done your simplex iteration. So only the thing is that you have to consider for the phase 1 as your auxiliary objective function. Once you will consider, do the iteration, and then if artificial variable is present, stop there and say my solution is infeasible. Otherwise, if it is not present and it has 0, then you can proceed to phase 2, and then you can find the optimal solution. And the same you can also do for some other examples, that you can solve minimize Z. Suppose the problem is given to you 4x1 plus 6x2 plus 5x3, subject to you have constraints 2x1 plus 4x2 plus 3x3 greater than equal to 32, and this is x1 plus 2x2 plus 4x3 greater than equal to 28. This you can try yourself, right? So this, when you have to do your phase 1, you have to convert it into the standard form. So when you have to convert it into the standard form, there will be subtracted your surplus variable. It will be minus S1, S2. And one more thing, because you have subtracted our surplus variable, so you have to add the artificial variable when you have to solve A1 and A2. And this was your 32 and 28. So when you will proceed to phase 1, you have your objective function minimize, because here is my minimize. I can take only A1 plus A2. Even when your objective function is maximization, even then you can take this minim as objective function that I have already told you, no issue. But you have to follow that criteria. If minimize objective function, your Zj minus Cj, only you can stop and it will be less than equal to 0. And all the constraints will be remain same. And this you can solve yourself. When you will solve it yourself, you will come to know your x1 will come out to be 0, x2 will be come out to be 22 by 5, and x3 will be come out to be 24 by 5 in your phase 2. Because in phase 1, your artificial variable will leave, and then you have to proceed for phase 2, and you will just calculate your fresh Zj minus Cj, and then you can do the iteration if required. Fine. So that means if artificial variable will present in phase 1, and which is not equal to 0, only then you will have your infeasible solution. Okay. Next, we are going to discuss some special cases, right? That we have done in graphical, that LPP is unbounded, infeasible, alternate optimal solution. So one case I have already discussed with you, infeasible solution. We have done one example correspondingly to that. The reason is that if artificial variable is present in the optimal table, and it is not equal to 0, then LPP has infeasible solution. That I have already told you, that if you have this condition, if you put the values of the variable in the given LPP or one of the constraints will not be satisfied. Actually, we add actually this variable. Suppose you have any region like this, I can show you graphically that why it has a this thing. Suppose one constraint is that that it is going towards down, that this is my feasibility, right? And I am in constraint in this. And my other constraint is only that it is like this. Suppose this thing, right? I am considering, and it is going upward, right? So actually this does not have any common region. So does not have common region, that means it has not feasible solution. So when we have started simplex, I have told you that what is your simplex? Simplex is nothing, but that is your vertex to vertex movement. So actually what we do, we take this as my artificial variable that we add, so that the equation which was earlier this and it shift to this line towards like this, right? Not even exactly like this. So it means it will become parallel to this, so that it can have one vertex correspondingly to that. So since this is a vertex, now I can move one vertex to vertex. For the simplex I can go, but because optimal solution is occurring at this point and this point is not included in that, just only to obtain from vertex to vertex, we have shifted that line to this line so that we can find the feasible solutions and we can do the simplex iteration. But this is, we have assumed if solution is lying on this, that means A is present. So that means you does not have your feasible solution. In this case, if you put your values in the given LPP, or one of the constraint will not satisfy. And if you are using two-phase method and artificial variable is present in phase 1 also, then you can also have your infeasible solution. The next we have discussed your alternate optimal solution. Alternate optimal solution, if you remember, that the solution is occurring, but that is giving me the same value. That means objective value should be same. My Z should be same for all the optimal solution. We have seen in graphical method that we have obtained alternate optimal solution. So how you check for your alternate optimal solution in your simplex iteration? Now, this you can check if Zj minus Cj is equal to 0 corresponding to non-basic variable. We know for the basic variable, my Zj minus Cj is always equal to 0. This we know for the basic variable. But if my Zj minus Cj corresponding to non-basic variable, if it is 0, then there exists alternate optimal solution. If there exists alternate optimal solution, then there exists infinite many optimal solution. So you can notice one example that you can solve. Even I'll just write the last iteration. So if you have solved the problem, that this is the problem, maximize Z, that is equal to your 4x1 plus 10x2 subject to this 2x1 plus x2 less than equal to 10, and you have 2x1 plus 5x2 less than equal to 20, right? And when you have to solve it by your simplex method. When you do it by simplex method, here you will add plus s1 plus s2, it will become. So when you will do its iteration, or I can say that you can construct a table taking your variable. And the third constraint, it is also, there is one more constraint, that is your 2x1 plus 3x2 less than equal to 18. That means plus s3 is equal to 18, and all my x1, x2 and all my s1, s2 and s3 all are greater than equal to 0. And this is 0 into s1, 0 into s2, 0 into s3. So if I tell you to construct a table with taking the basic variables as x, s3, right? That I have added in the third, x1 and x2. So you can also construct by finding the basic variable and finding B inverse, the B matrix. B matrix is, what is that? Corresponding to your basic variable 0, 0, 1, 2, 2, 2, and this variable, this is your x2, this is your 1, 5, 3. You will solve this, find the inverse and calculate CBB inverse. So when you will find its optimal table, this is coming out to be like this. You can solve the calculation. I have already told you that if this thing is given to you, you can calculate your alpha j. Alpha j will be nothing but that will be your B inverse into AJ. That are your entries of your columns here, x1, x2, s1, s2 and s3, and the solution and your xb you got when you multiply your cb into your right hand side, and the basic variables that they have already given you, that you have to use the basic variable. That you have to use basic variable as your s3. That means s3 is my first variable and x1 is my second basic variable. x1 is my second basic variable, x2 and corresponding to cost s3 is 0. x1 की cost कितनी है मेरी 4, x2 की cost कितनी है 10, right? And you can calculate alpha j's entries, and this entries when you will calculate, it is coming out to be your 3, right? It is coming out to be your 15 by 4, and that you can calculate 5 by 2, and these entries you will calculate by this formula, which is obviously because S3 is basic variable. I know this entry will be my 0, 0, 1. X1 is basic 0, 1, 0. X2 is basic 0, 0, 1. These entries you can calculate even with this formula. And these entries are coming out to be your minus half. This is coming out to be your 5 by 8. This is coming out to be your minus 1 by 4. And this entry is also coming out to be minus 1 by 2, minus 1 by 8. And this is coming out to be 1 by 4. And this we have right to Zj minus Cj. You know Zj minus Cj formula is, that is Cb into alpha j minus Cj, that you can calculate, and it is coming out to be your 0, 0, 2, 0, 0, 0, 0, and this is coming out to be your 2, and this is your 0, and the solution here it is this you can calculate the solution, that is 4 into that is 15 plus this you can calculate 4 into 15 by 4 plus 10 into your 5 by 2. If it is not given to you, that is your z value. Z is your cb into xb, right? This z, right? Now you can see what are your basic variable. Basic variable is s3. Corresponding to s3 I have 0. x1 is my basic variable, corresponding to x1 is 0. x2 is my basic variable, my zj minus cj is 0. But s1 is my non-basic variable, and corresponding to non-basic variable I have this entry as 0. That means there will exist your alternate optimal solution. Now the question will come, how you can find that alternate optimal solution? You can find that optimal solution in the way that you can take this as my entering variable. If it is entered, you have to decide your leaving. This minimum ratio, how you calculate minimum ratio? xb divided by alpha j, and alpha j should be greater than 0. So when you will calculate for this thing, you will not calculate because it is negative. For this thing, you will not calculate, it is negative. And obviously this has become my pivot element. So this is pivot element. This means we have to make this as 0, this as 0, this as 0. And this will come zj minus cj. S3 will be on its place. X1 will be replaced by S1 and X2 will be on its place. So when you will apply your row transformation, making it as 1 and 0, these entries are coming out to be your 4 by 5, 8 by 5, 2 by 5, and this entry is 0. This is 0, 0, 1. And this is coming out to be minus 3 by 5, minus 1 by 5, 1 by 5. This is coming out to 1, 0, 0. This is coming out to be your S1 is basic. So it is coming out to be your, this is 0, 1, 0, and this is this is 0, 0, 0, 0, 1, 0, 1, 0, and this entry will come, this will be your minus 3 by 5, and this will entry be your minus 1 by 5, and this is 1 by 5, and this will be 1, 0, 0, and solution also coming out to be your here 6, 6, 4, and your Zj minus Cj, if you will apply your row operation, this is coming out to be like this, and you can calculate even the value you got here, that will be your 15 plus 25 that you got as your 40. So the same value you will get over here, 40, right? Now you can see your optimal value still has same answer, but your optimal solution has changed. So what earlier you have optimal solution was your, if I'm writing here x1, x2, s1, s2, s3, and because we got two solutions x1, x2, s1, s2, s3. In the earlier situation, I have my x1 was 15 by 4 and my x2 was my 5 by 2. S1 0, S2 0, S3 was 3. And in the next situation, I got X1 as 0, X2 I got this as my 6, that is this is not 40 actually. You can calculate the 4 will be cancelled and this will be 5 into 5, 25, and this is 40, right? So this is 6, 0, 6, S1 we got, this is 6, S2 we got 0, and S3 we got here as 6. No, X2 we actually got 4. This is quantity, this is 4, and this is 6 and 6. Now these are two optimal solution corresponding to that my Z value is 40. I have told you when there exists more than one optimal solution, there can be infinite many optimal solution. How you can find this? You can take A1 plus A2 and you can give any value to your A1, A2 such that their sum will become 1 and it should be greater than equal to 0. Then all will be my optimal solutions, and the optimal value corresponding to every solution, it will be my 40. Clear? So in this case, you can find your alternate optimal solution. Next, we are going to discuss the third, that is my unbounded case. Unbounded is when there is variable to enter, but we fail to find minimum ratio. In that case, we have unbounded solution. That means आपका zj minus cj में से आपको entering variable मिल रहा है, but you do not have any leaving variable, then you will have your. So you can notice in the example, if we consider maximize z 4x1 plus x2, if you will solve this problem, x subject to x1 minus x2 less than equal to 1 and minus 2x1 plus x2 less than equal to 2, and you have x1, x2 greater than equal to 0. If you remember unbounded, we have done when we have graphical method, my feasible region becomes unbounded, and at that point my LPP also becomes unbounded. So that the case of LPP. So when you will solve this problem, obviously there you have to add your slack variable so that you can solve it. So if I am adding S1 in the first variable and I am taking S2 in the second variable, so when I solve this and I got X1, X2, my S1, S2, you can do the iteration yourself. I am writing the last optimal table which is coming out to be the last optimal table is, you can perform the iteration yourself. So it is coming out to be your 0. This is Zj minus Cj. This is 0 minus 5. This is 4. This is 0. And here my solution is coming out to be your 4. And this entry is my 1. This is 4. And my basic variables are x1 and s2. Even after one iteration, you will get this answer if you will perform iteration yourself. Minus 1, this you got 1, 2, 0, 1. Now you can notice here that this is my maximization problem. So I can stop only when my all Zj minus Cj will be greater than equal to 0. That is my optimality condition. But here you can notice my minus 5 is already here. So that means this is my entering variable, right? And I have to find the minimum ratio, but my minimum ratio says I can find xb by divide by alpha j, but alpha j entry should be greater than 0. So here you cannot divide 1 by minus 1 because minus 1 is less than 0. You cannot divide by minus 1, it is less than 0. So here you have entering variable, but you do not have leaving variable. So in this case, your LPP is unbounded, right? Now we have also discussed a case in graphical. Even my feasible region was bounded. Even my feasible region is unbounded. But at that step, I got my LPP bounded. So what will be the condition there? So that means if you have like this in the alternate optimal solution, if we go, right? If you are going to the alternate optimal solution, this is your last optimal table. You got this value as my 40, right? You got. But to corresponding to your non-basic variable, this variable is 0. And you cannot say that it is alternate, right? Suppose I have all these entries are negative. So you cannot enter that variable in that sense, right? You can understand because this is my non-basic. When I have to show alternate optimal solution, I have entered this variable and I have shown you the iteration. But suppose this is 0 and you are entering it, but you are unable to find leaving variable. So in that case, when you have corresponding to any of your non-basic variable is 0, right? And you do not have any leaving variable. So you have that, in that case, you have LPP is bounded, but feasible region is unbounded. Got my point? We have done the example in graphical method, right? So the last is, that is your degenerate. We have also obtained degenerate basic feasible solution. Degenerate क्या होता था? अगर मेरे किसी any of my basic variable comes out to be your 0, नॉट Zj माइनस Cj, अगर मेरी बेसिक वेरिएबल की भी किसी की वैल्यू 0 आ जाती थी, देन आई से दैट इज माय डीजेनरेट बेसिक फिजिबल सोल्यूशन. सो द केस हियर इज दिस, इफ देयर इज अ टाई for leaving variable, that means if you are finding the minimum ratio and you have got the minimum ratio for 2 or 3 variables, then next solution will be degenerate solution. The next solution will be your degenerate, because suppose you got tie for 2 variables. Suppose I am saying minimum is for the first is 3, 3. Now you can take any one leaving variable, but the next iteration when you will take out, this will become entry will become 0, and that you have degenerate basic feasible solution, right? So degenerate can be temporary or permanent. If temporary means if you have basic variable, sometimes 0, it leaves your basis, and then in the last you got as basic variable जो आपके 0 नहीं थे, but हर बार अगर आपको 0 मिल रही है उसकी value, that means in that case you have permanent degeneracy. So these are the cases that you can notice. Next also can be some tips, like we have solved simplex method. Suppose the question is given to you that you have to maximize z, that is your 2x1 plus x2 plus x3, subject to you have constraints x1 minus x2 equal to 0, 2x1 plus x3 is equal to 3 and your x1, x2, x3 greater than equal to 0. So now the question is given to you. You have equal to constraint. So you can apply your two-phase method or BGAM, but it is given to you that you have to solve it by simplex method. Since you have to solve the simplex method, then you cannot add your artificial variables. So what you can do, now you can notice that whenever we have started simplex iteration, so we can start with the table only when we can have identity matrix. So you can notice over here, my x1's column is 1, 2, and this is my minus 1, 0, 0, 1, 0, 3. That means for the second variable, I have 0, 1, so I can take x3 as basic variable. But x2, I can take basic variable only. What will, this should be minus. So we can, when we have done earlier, then I cannot multiply by minus because I cannot take right hand side to be negative. B should be positive or non-negative. So, but here your B is 0, so you can multiply it with, so it will become minus x1 plus x2 equal to 0. So that will become minus 1, 1, and this will become 0. So that means you can take your basic variable and x2 and x3, calculate your zj minus cj correspondingly to that, and you can proceed in like that. In the same example, you can take the next case, that if you take, you have maximize z, that is 2x1 minus plus x2 plus 2x3, subject to you have x1 minus 3x2 equal to 0. You have 2x1 plus 5x3 equal to 3. So when you have to start the simplex iteration, what you can notice over here, this thing, that when you will do, here you can take the columns is, this is 1, 2, this is minus 3, 0, and this is your 0 and 5, and this is your solution 0, 3. You can make this identity matrix by dividing it by 5. So I can take, this is my 2 by 5, this will become 1, and this will be 3 by 5. I can have identity matrix when I have x2 and I'll multiply it with negative sign because it will not affect. Then you can calculate your zj minus cj. So these are some special cases in the simplex method. And even if the question is given to you 2x1 plus 5x2 plus 7x3, 3x1 minus 7x2 plus 4x3, you have to solve this, right? And the objective function is not given to you. The objective function is not given to you, then you can assume auxiliary objective function and you can start with the two-phase method or BGAM method. You can take, if you are applying BGAM method, you can take, if you are taking objective function m, that it will be minus m into artificial variable. And if you are doing phase 1 and you need to have only your artificial variables, in that way you can proceed. Okay, thank you.